Alrighty, this video is going to cover problems found on page 7 in our stoichiometry packets. So I'm going to do a few examples here. Basically what we're doing is we're still just building upon our knowledge of the flux capacitor, right? Where we're taking moles, we're putting it in the middle, particles up here, liters of gas over here, and mass down here, right? And as we go through this, we'll use it as we go, right? But anytime we're moving away from it, we're multiplying. Anytime we're coming back, we're dividing, all right? And the different things, obviously, they change as we go. So here we're dividing, and here we're dividing. Here it's here it's 6.02 times 10 to the 23rd, here it's 22.4, and here it's the molar mass. So here we go. So question number 1 is kind of pretty simple, okay? Question number 1A says, okay, what is the molar mass of neon? Well, what you would do is you'd go to the periodic table, you'd find the molar mass of neon, you'd round it, okay, and do it accordingly. Actually, you know what, let's not even do that. Let's do 1B. Because that one, the first one's just too easy. So, NaF. So what you do with this one is you go find sodium, which is 22.99. And then you go find fluorine. Now, fluorine, I believe, is 19.0. Why? Because it gets rounded up. It's like 18.999 stuff. When you round it to 100th place, it becomes 19.00. So when you add those two things together, you get 41.99 in grams. Okay, so that's 1B. Now, let's do an example of something where we're up in, let's do 2B now. So it says, okay, find the number of moles, so the moles, if you know that you have 10 grams of NaF. So you have 10.0 grams of NaF. So where we are is we're mass. So to go from mass to moles, we divide by, what we know divide by is by the molar mass of the object. So what we end up doing here is we take 10, we divide it by the molar mass, which we just calculated to be 41.99. We have 3 sig figs in our number to start, therefore our answer should also have 3 significant figures. So when we do the math on that, we get, I get 0.238 moles. 0.238, and that's moles of NaF. Continuing along, let's do 3A. I'm doing all the ones basically that involve NaF, just so we can, for time purposes mostly. So it says, okay, if I give you 2.50 moles of NaF, it wants to know now what is the mass. So now we're going moles to mass, so we're multiplying by the molar mass, which we found out here is 41.99 grams. Again, we start with 3 sig figs, we finish with 3 sig figs. So when we do the math on that, we get 105. It's like 104 and change, right? But when we do it with 3 different figures, this becomes 105. The label is grams NaF. Put a box around it so Mr. Gerby knows what your final answers are. And that's always a good idea, to just put boxes around it so that I don't go to grade something and you don't, wonder what I did. Okay? Let's go all the way down to 6B. So 6B, and again, I'm keeping with this NaF thing. So 6B. 6B says this. If we have 10.0 grams of NaF, how many particles is it? So now we're going to go mass to moles, moles to particles. So when we do that, we're going to multiply. We're going to multiply by 6.02 times 10 to the 23rd. So what we do is we take 10.0, and to go from mass to moles, we divide by the molar mass. So we take 10.0 grams, we divide it by 41.99 grams, which we just did in a previous problem. And we got what, 0.23, wasn't it like 0.238, right? And then, so right, wasn't that right? Yeah, 0.238 moles. of NaF. Now, in order to go from moles to particles, we multiply by 6.02 times 10 to the 23rd. So we take 0.238, and we multiply it by, I always put in parentheses whenever it involves a scientific notation. So times 6.02 times 10 to the 23rd. We have 3 sig figs. Therefore, when we get our answer, we're going to want 3 significant figures. So we do the math on that, and we calculated it out to be, I get 1.43 times 10 to the 23rd. Now, the label on this is NaF, right? So that's a metal and a nonmetal. Therefore, this is formula units of NaF, because we call things that are a metal and a nonmetal formula units. If it was just a single element, we would call it, right? We would call it atoms. If it was 2 nonmetals like water, we would call it a molecule. And that's 1 through 6b. Now, number 7 is an interesting question. It's a real thinker. And what you have to do with number 7, I don't want to let the cat out of the bag just yet on it. Meaning, I want you to have to think. But it says, what mass of iron contains the same number of particles as 10 grams of neon? Well, what I'm going to tell you is this, that 1 mole of neon would be equal to 1 mole of iron. Even though they're going to weigh different amounts, or they have different masses, they're still equal, because a mole means 6.02 times 10 to the 23rd atoms of neon. And this means 6.02 times 10 to the 23rd atoms of iron. So what you really have to do here is you have to take the grams of neon, turn it into moles. And that'll be the exact same number of moles as iron. Okay? And then what you would do from there is you would take that and turn it into mass. I want you to see if you can figure that out. So again, you're going to go grams to moles. This would be the same number of moles. Because why? Because it's saying what would contain the same number of particles. Particles is moles. Then you take this, turn it into mass, right? When you go from moles to mass, you multiply by the molar mass of iron. All right? I want to see if you can figure that one out. So there's a bunch of examples off of page 7.